period, so I can don't mess up. Okay. So I think it's working. So it says, how is the word rate of, so we did slope yesterday. We're going to talk about rate of change today. And using slope. So, were there any questions on last night's homework, actually? I should probably ask that first. And then we'll check that later. Hopefully we did okay with the equations. What are the equations? X equals, Y equals. So how is the word rate of change related to the definition of slope? Based off of what we learned yesterday. And maybe flip over to your previous page and look at the definition we wrote for slope. We said it's the ratio of the vertical change to the horizontal change between any 2 points along the line represented by the letter M. So basically, it's all about how much something changes related to something else, which is a rate. So you can say, remember the change, we used the little triangle symbol. That's the change of y over the change in x. And I guess that's just a little question for discussion. Nothing you need to really write down besides that. So a rate of change compares a change in one quantity, a change. I go back to Mrs. Kelly. She's not happy about the situation going on out there. Are you in your class? They're fixing they're fixing something, like, I don't know, the ceiling or the roof, and they got these maintenance people right outside of her room on like big ladders. One of the big ladders, so everybody is distracted. Then one quantity, which is your dependent variable, right? Because the y is the dependent variable. And the variable, in other words, your y to a change in another quantity, which is your independent variable. I'll just say independent variable, which is your x. So here's an example. If you are paid $60 for working 5 hours, then your hourly wage is $12 per hour. So $12 per hour is a rate of change, describes how your pay increases, right? It's positive with respect to time spent working. So, increases. And so we can calculate the rate of change of real world situations because we know how to find the slope. So the thing we need to do though is to convert. So we have this information in the table, we just need to convert it to points so that we can find the slope. So the table shows the cost of using a computer at an internet cafe for a given amount of time. Find the rate of change in cost with respect to time. And so this is increasing at a constant rate. And if we wanted to find the rate of change, we would have to find the slope. So whenever you see rate of change, I put a box or underline this and say slope. It's asking you to find the slope. So imagine time being your x and cost being your y. So you can convert all of these to coordinates. So this would be 2,7. This one would be 4,14. And this one would be 6,21. So you can take any two of those points and find the slope between them. So let's just pick the first two. So remember y2 minus y1 over x minus x1. So 14 minus 7 over 4 minus 2, which is 7 over 2, which is 3.5. So that's 3.5 is the rate of change, but we need a label. What's the label? Yes, I just say dollars per hour. The dollars per hour. So when you're finding a rate of change, the units have two parts to it. You should have one part and then the per part. So something per something. Miles per hour, dollars per hour, something per minute. Now, could you have just like seen that from the table that it's increasing by 3.5 each time? Sure, but sometimes it might not be that clear. Alright, so for this one, do the same thing. Table shows the distance a person walks for exercise, find the rate of change in distance with respect to time. So for every 30 minutes, they're going up 1.5 miles. So if we convert this to points, then this would be 60,3. I can find the slope between those 2 points. So that would be 3 minus 1.5 over 60 minus 30. Oh, wait a minute. No, that's great. So 3 minus 3.5 is 1.5. And then that's divided by 30. So what's 1.5 divided by 30? 20. 60, 30 divided by 1.5 is 20. We need a calculator. Get out your calculator because you're going to need it. Something miles per minute. Blank miles per minute. Aaron.
25 miles per 10 minutes.
So how many per 1 minute?
2.5.
Right again. 0.05.
Oh, 0.5.
So 0.05. That was a creative answer. All right. And yeah, we could have done this point and done any two of these points. So yeah, so maybe this number isn't as obvious to tell from the graph. Wait a minute. Is that the right unit? That's right unit. Yeah, miles. This is miles and sorry. Second. Okay. So then you're going to see something like this, which you might be seeing things like this in science around this time. Is that a yes? No. You know what I'm talking about? No. But like distance time graphs, you're doing that science? No? I saw someone in Bill Garden did it. Community theater performs a play each Saturday evening for 10 consecutive weeks. The graph shows the attendance for the performances in weeks 1. So in week 1, there were 124 people. In week 4, there were 232 people. Week 6, there was 204 people. And then everybody was like, we don't like this play anymore. We're not attending. In week 10, there were only 70 people. Or by the time week 10 happened, everybody else had probably already gone to the play. So they're getting like the last people. Describes the rates of change in attendance with respect to time. So when we do a question like this, what we're going to do is we're going to section off each interval and find the slope of each interval. So there's going to be how many different slopes we're going to end up finding. Yes, maybe. Right, because we'll have section 1, section 2, and section 3. So each of those segments, we're going to find the slope between them. All right, so I'm going to assign, no, maybe we'll do all of them for this one. We'll do all of them together. So let's do from weeks, from week 1 through 4. Let's find the slopes for those. Oh, hold on a second. So y2 minus y1. So 232 minus 124 over 4 minus 1. So simplify that, divide by 3, and get 36 people per. So and actually we could say attendance increased at a rate of 36 people per week. So attendance, you might want to write small. Attendance increased at a rate of 36 people per, at least write out that first one and then we can abbreviate the other ones. That's my first segment. What about our second segment? So weeks 4 to 6. So we'll do y2 minus y1. To do the left point or the right point minus the left point. So 204 minus 232 over 6 minus 4. I got a negative answer, right? Because it's sloping down. What do you get? Negative 14. So what does that mean? How would we write our sentence here? Describe the rate of change. It went down and it decreased. So it's going to decrease 14 people per week. So attendance decreased 14 people per during that section. And then, yeah, from 6 to 10 was either just a bad time or just by that time everyone had seen the plan. So for 6 to 10, 72 minus 204 over 10 minus 6 equals what? Negative 33. So decreased 33 people per week. So do you see what I mean about, the first one, write the full sentence, and then repeat it. So when they're asking you to describe rate of change, you have to first actually find the slope so that we know the number that represents the rate of change, and then describe it. So saying what that means. So it increased, if it's positive, that means that it increased that many per week, or if it decreased, then if it's negative, then it decreases that many. Now, wait, go back to your previous page, because I want to talk a little bit more about what those numbers mean. So notice, for this one, we got 36, this one we got 14, this negative 14, this one we got negative 33. Which of these segments is the steepest? Yes, 36. Which one is the least steep? Nathan? Yes, yes. You might think negative 33 is less steep, but that's actually the second steepest. When you look at steepness, you're going to disregard the positive or negative sign and just base it off of the absolute value of the number. Because look at this, if you were riding your bike down this hill, that would be less steep than if you rode your bike down that hill, right? So this has a greater slope, it's just that it's more negative. What did you say? Well, either way, we're still gonna go down.
The second.
Yeah. First thing, first.
Okay, so anyways, I think that was all. So the steeper slope has a greater rate of change, positive or negative. Because sometimes, for example, what if this was negative 40? Then that would be the steepest. Even though that's for positive 36, that's still steepest. Okay, let's do another one. It says the student commutes from home to school by walking and by riding the bus. Describe the student's commute in words. All right, so what's happening so right here, here's the time, and here's the distance they're walking from home. Student commutes from home to school. So here's home, here's school. So what's happening during this section? It says by walking and riding the bike. So what's happening during that section? What did you say? Depression. They're walking to school. Oh, we just lay it on our heads all day. Yeah. Yeah, they're walking to school. So here, walking at a, you could say a moderate rate. So I guess section 1, maybe I'll put 1. So walking to, where do you think they're walking to? Walking anywhere? Yeah, they're probably walking to the bus stop. Walking to bus stop. It doesn't say exactly what the distance is. Like how many, are they actually walking 1 mile or is that just half mile? Or is that 0.1 miles? Maybe they're just walking to the end of their driveway. And then what's happening in section 2? What does that mean if it's flat? Right, so they're not going anywhere. So if it's flat, that means they're not traveling any distance and they're just waiting for time to go on. So during section 2, they're waiting for the bus to come. Hopefully it's not raining or cold. Because the slope is 0 here. That's what waiting. And then 3, the slope is steep, very steep, so that's going to be the part where they're riding the bus, where the velocity of the bus is a lot greater than your velocity of walking. Riding the bus. And is steep. Okay, so you see an exit ticket, number 1. So that's exactly what we did. So if you want to work with your table on this, I don't care, that's fine. But go ahead and get that started, and then for the rest of the time to work on homework or test prep. And if you had any questions about last night's homework, feel free to ask. So exit ticket. So do it just like we did with the other one. Just do the first one for now, okay? So I'll give you maybe 5 minutes to do the first one. So remember, you should have 3 different slopes and with description. So are increasing, decreasing, section 1, 2, 3. It's computers sold per day.